Point P and Q lie on a straight level road. The car P passes with constant speed of 13 meters per second and continues at this speed for 9 seconds. The car then accelerates uniformly for 5 seconds to a speed of 28 meters per second. Finally, the car decelerates uniformly from 28 meters to rest at point Q. The car travels 98 meters while decelerating. Draw a speed time motion of the graph from car P to Q. And then we're going to have to do all the other stuff. All right, so I'm going to get my graph up and running now. So here we go. Okay. Distance time graph, sorry, velocity time graph, yeah? Velocity time. Okay. Start at 13 in the air. So you start at 13 and you continue that for 9 seconds. Okay. So for argument's sake, I will call that 9 seconds. Okay. Then we accelerate from 13 up to 28, which takes 5 seconds. Hold on that line. 13 up to 28. Okay. That's 28. And that apparently took 5 seconds. So it took 5 seconds. Okay. Does it? So we're going to go straight down from 28 to 0. And your graph should look something like this. Now, 28 to 0. Is that okay with you guys? Now, would you agree that the height of this line is 28? What's the area of this triangle? Can anybody tell me? It's 98 because it traveled 98 meters during deceleration. Okay, call this time x. So a half 28 times x has to be 98. I think it's 98 divided by 14, is it? Who got an x value of 7? All right, we got an x value of 7. Cool. Okay, happy days. So that means the time is 7. So we have 7 and 28. Now, let's go and park that 28 over to the side for a minute, okay? Now, do you see this triangle here during the acceleration period? So I'm just going to mark it off here. So it's like this, this yellow line and this red line. Does everybody see the yellow and red lines respectively? What length is the red line? 5. What length is the yellow line? 15, yeah? And what we said is slope or tan of the angle gives you your acceleration. So what's 15 divided by 5? 3. Your acceleration is 3 ms minus 2. Tan of the angle or slope will give you the acceleration. Now, likewise earlier with the larger triangle, we know that's 28 and 7 now, don't we? For this large red line here. So what do we think the slope of that line is? Yeah, tan A, call it, will be 28 over 7, which is 4. But because we're slowing down, it's actually a deceleration of -4. Cool with that? Okay. Now we're going to play a game of can we get the areas? Okay. You know the area of the last one, don't we? 98. That's a distance of 7 earlier. Okay. Now we know that that's what you say area 15, was it? Yeah, that's 5. What's the area of that triangle? A half of 5 multiplied by 15, which is 37.5. Anybody? 37.5, half of 75. Because 5 times 15 is 75. Now, what about the area of this little rectangle down here? It's 13 high and 5 across. 65, exactly. So we're going to make that 65. And then the area of this rectangle here, 117. And then what we're going to do is we're going to add all these together. So we're going to add all these numbers together, and C over there is going to give you the answer. 378.5, that sounds good to me. And it is the answer that's in the solution. So 378.5 meters, yeah? Now it's looking for average speed. So what do you do for average speed? Total distance divided by total distance divided by total time, is it? So total distance 317.5, total time 21. Because 9 plus 5 is 14, 14 plus 7. And then you throw it in a calculator and you get 15 points. And round off to 1, 2 or 1, 1, 1, 2 meters per second. 3, okay. Points P and Q lie on a straight level road. The car travels along the road in a direction from P to Q. It is initially moving with a uniform speed of 14 meters per second. As it passes P, it accelerates uniformly for 8 seconds until it reaches a speed of 30. Then the car decelerates uniformly from a speed of 30 to a speed of 22 meters per second. The car travels 52 meters while decelerating. It now continues at a constant speed of 22 meters for 10 seconds and then passes Q. Okay, so we're going to have to draw a diagram for this. So we're going to draw the speed time or velocity time diagram first. So here we go. Okay, you can be velocity, you can be time. Let's begin. We start at 14 and it takes us 8 seconds. Takes us 8 seconds to get all the way up to. Takes us 8 seconds to get up to 20, up to 30. There you go. So that's 30, 14 up to 30, okay? Then you immediately decelerate to 22, which is around here. And then you continue at 22 for another 10 seconds. So if I start drawing some lines down here, we can split up the time accordingly. Now I'm going to split that up into a triangle as well. I'm also going to split this one up into a triangle. Now, here we go. Let's do it. Okay, the first one is 8 seconds. The second one, the deceleration region. As it passes P, accelerates uniform for 8 to 10. It doesn't give us the time for that one. But what it does say is that area A and B combined. What's A plus B? 52. So I do know that much. And then I know it goes to 22 and it does that for 10 seconds at 22. So easy information to fill in is that this last rectangle is 220 meters. Is that okay? It's 22 by 10. That's easy money. Now, we're going to represent time with a letter X. Is that okay? That the time of that takes to do the deceleration is X. Now, the first thing you're going to do is, what is the height of rectangle B? 22. So it's 22 across, X up, which is going to be 22, X. Okay. The next one is 14 up to 30 is 16. No, sorry, no, I'm not doing 14. I'm doing 30 down to 22, which is 8. What's the area of that rectangle then? Or triangle, I mean, triangle A. A half of A times X, which is 4X, yeah? Now combined, what's A and B combined then? 4X plus 22X. We're saying that 26X equals 52. This one tells us that X equals 2. Done. Okay. What does it want from me now? It wants the acceleration, doesn't it? So we're going to do the height of this triangle, which is, anybody, this height here? 16. The base, 8. 16 divided by 8? 2. 2 meters per second squared. That's handy, wasn't it? Now the deceleration. What's the height of this triangle? 8. Yeah. The width or the base? 2. So what's 8 divided by 2? 4. But because it's a deceleration, minus 4. You cool with that? Now, find the distance of P to Q. No hassle. We know that these two distances combined are what? 52. Because that's what was told us earlier today, right? So that's 52. Now, what we're going to say is what's 8 times 14? 112. And then the height of this triangle is 16, isn't it? So it's going to be a half 8 times 16, which is 64. Okay. And then once C added them all together, what did you get? 448. When you add all of these together, you get 448 for the total distance. Okay. 448 meters. Now your average speed, what do we think? 448 divided by 20, because it's 8 plus 2, 10 seconds, 10 plus 20. And what do we get there? 22.4 meters per second. Velocity, not acceleration, so no squared on that one. Now, what's the time the car is moving or above average speed? Interesting. Oof, this is tough. Okay, I think here's what we're going to zone in on. Are you ready? Okay, we're going to zone in on a region. See this 22, just slightly above that, isn't it? So what I'm going to do is I'm going to put a line just above the 22. Okay, I'll call it a yellow line. Okay, this yellow line is at 22.4. Is that agreed? Okay. Do we really want yellow? Yeah, I do. Right, 22.4. So, if you will, it's this region here. It's this region from here to here. That's the time that you spend above 22.4, agreed? Now, I can break that up into two little triangles, okay? Now, here's the deal. We know that, see this, we'll call it triangle X and triangle Y, is that okay? Triangle X and triangle Y. Now, with triangle X, we're after the time, aren't we? So we'll just call it T, is that okay? Now, and what's the height of this? Remember, it's 22.4 all the way up to 30. So what is the height? Now, grand. We also know the acceleration. What's the acceleration? Yeah. So the slope, when you divide 7.6 by t, the answer has to be 2, because the acceleration remains the same. So what does that mean about t? T is 3.8. Now, we're going to do the same trick on the way down for triangle Y. Because what can we say about triangle Y? Let's call it T1. Is that okay? What's the height of triangle Y? I think it's also. But what's the deceleration? 4. So 7.6 is 4 times bigger than the time. So what's 7.6 over T1 is 4. Don't mind the minus, that doesn't matter for much here. So what do we think? What's 7.6 divided by 4? 1.9. Then add them both together. 3.8 and the 1.9. 5.7.